Right now, something enormous is stirring beneath the Bismarck Sea, and almost nobody outside a small circle of scientists has noticed. A brand new volcano has been erupting nonstop for more than 2 months, and just weeks ago, the seafloor beneath it cracked open with an earthquake strong enough to be felt on land. This is currently the most active submarine volcanic system on the planet, happening somewhere so remote and so deep that we're basically watching it through a keyhole. Stick with me, because by the end I'm going to walk you through a study that just doubled the number of giant undersea volcanic craters known to science, and explain why the biggest eruptions on Earth are consistently the ones we notice last. If stories like this interest you, subscribe now, because we cover breaking Earth science exactly like this one every week. Picture this. Somewhere out in the Pacific right now, an actual natural disaster is unfolding on a scale that would dominate the news for weeks if it were happening on land. And outside a handful of volcanologists, almost nobody has heard a thing about it. No dramatic lava footage, no glowing mountain on the evening news, just a quiet trickle of satellite images and seismic readouts most of the world will never see. That gap between how enormous this event actually is and how little attention it's getting is really the whole point of this video. The location is the central Bismarck Sea, roughly 130 kilometers southeast of Manus Island, Papua New Guinea. On the 8th of May, 2026, around 1:15 in the morning Universal Time, seismic instruments run by the Rabaul Volcano Observatory picked up the unmistakable signal of magma forcing its way up through the seafloor. Within hours, a plume broke the surface. What made this genuinely strange is that nobody even knew a volcano was there. The eruption revealed a completely unmapped underwater mountain, since given a working name, Titan Ridge. It sits only about 16 kilometers from the site of a previous submarine eruption back in 1972, in a stretch of ocean only added to a proper geological survey map 2 years earlier in 2024. Before that, this feature was essentially invisible to us. By the 15th of May, satellite imagery confirmed the eruption wasn't coming from one single vent. It was coming from at least 2 separate eruption centers, sitting about 2.5 kilometers apart, both actively blasting steam and ash into the sky at the same time. This was never some minor seafloor hiccup. This is, and honestly still is, the most powerful volcanic eruption happening anywhere on Earth right now, more than 2 months after it started, and as of the most recent reports, it shows no real sign of stopping. Almost everything we know about this eruption has come from orbit, rather than from anyone standing near it. The European Space Agency's Sentinel-2 satellites, along with instruments feeding NASA's Earth Observatory, have captured huge plumes rising off the water. Discolored patches of ocean stretching for kilometers in sickly greens and browns and enormous rafts of floating pumice drifting across the open sea. Landsat 9 caught the eruption just 3 days in, showing closely spaced plumes rising from what researchers called a growing underwater volcanic platform. Steam and ash have climbed to somewhere between roughly 10 and 20,000 feet, high enough to matter for regional aviation, even without punching into the stratosphere. For the people living near this, it isn't some abstract scientific curiosity. Back in early June, rafts of floating pumice began drifting northwest and piling up along nearby coastlines, clogging harbors and fouling the water. Local reports describe the rock-smothering fish, coral, and seagrass beds entire communities depend on to survive. This is the part of an underwater eruption people tend to overlook. It doesn't need to physically reach a town to hurt people. It can reach out silently across the ocean and choke the fishing grounds a community relies on, while the volcano responsible stays completely hidden, kilometers beneath the waves. Right now, a genuinely serious lineup of institutions is watching this event unfold. The Rabaul Volcano Observatory holds the frontline seismic picture on the ground. NASA's Earth Observatory tracks it from orbit. Germany's Geomar-Helmholtz Center for Ocean Research has been involved since the first days, having helped chart this stretch of seafloor in the first place. Volcano tracking. Groups worldwide have been publishing near-daily updates as the eruption evolves. But here's the uncomfortable truth underneath all that attention. Even with every one of these organizations watching closely, we are still mostly guessing at the finer details, simply because there's an enormous amount of water sitting in the way. And a few weeks ago, the ground beneath this entire system reminded everyone how restless it has become. On the 13th of July, 2026, a magnitude 6.4 earthquake struck the Bismarck Sea directly, roughly 192 kilometers, southeast of the town of Lorengau, well within the same broad tectonic zone as the ongoing eruption. The quake was shallow, only around 10 kilometers deep, and strong enough that tens of thousands of people across nearby towns reported feeling it. Tsunami warning centers quickly confirmed there was no wave threat. But an earthquake of that size, striking while a major eruption is already underway a short distance away, is exactly the kind of event that makes volcanologists lean in. It tells you the ground under that eruption is still actively shifting, still under real stress, still very much alive. Now, any honest scientist will tell you a single magnitude, 6.4 earthquake doesn't automatically prove some dramatic escalation is coming. The Bismarck Sea sits right where several small tectonic plates grind against each other and earthquakes in the magnitude. 5 and 6 range happen there dozens of times a year without incident. Our brains are naturally wired to spot patterns even where none exist. That caution is fair. But the real reason this earthquake matters isn't that it proves a chain reaction is underway. It's that it points toward a bigger, overlooked truth. The overwhelming majority of the planet's volcanic and seismic activity happens underwater in places we barely monitor. And every so often, the seafloor sends up a signal loud enough that we finally take notice. Which brings us directly to the discovery that reframes this entire story. In July of 2026, a team of researchers published something that deserved far bigger headlines than it got. They took an algorithm originally built to identify impact craters on the surface of Mars and pointed it instead at detailed maps of our own ocean floor. What it found was genuinely staggering. It identified 73 previously undocumented submarine calderas. A caldera, for anyone unfamiliar, is the enormous bowl-shaped scar left behind whenever a volcano erupts so violently that its own emptied summit collapses in on itself. These aren't small features. They're the fingerprints of the single biggest eruptions any volcano is capable of producing. To really understand why finding 73 of these in one pass is such a shocking number, you need to know where we started from. Before this survey, across the entire history of this branch of science, only 78 submarine calderas had ever been formally cataloged anywhere on Earth. So a single study using a repurposed Mars mapping algorithm ended up more than doubling the total number of these giant volcanic structures that humanity actually knows about. And it gets even more humbling than that. Of those 73 newly detected calderas, only a small handful had ever been independently confirmed by any other method. The rest were essentially invisible to us, right up until a piece of software originally trained to look at an entirely different planet went looking specifically for them. The reason any of this is even possible comes down to a somewhat embarrassing fact about our own planet. We have mapped the surface of Mars in finer detail than we have mapped our own ocean floor. Our oceans cover roughly 70% of Earth's surface, and the seafloor represents the single largest volcanic province on the planet. And yet, only a small fraction of it has been surveyed at the resolution you genuinely need to pick out an individual volcano with any confidence. Estimates vary, ranging from under 5% mapped in real usable detail up to about 25% under the most generous figures. Either way, the conclusion stays the same. The vast majority of the seafloor remains, for all practical purposes, unexplored territory. There could easily be hundreds or even thousands more calderas down there. We simply haven't looked closely enough yet to know. Here's a fact most people never learn in school. When you picture a volcano, you're probably picturing a cone-shaped mountain on dry land, something like Vesuvius or Fuji or Mount St. Helens. But those examples actually represent the minority. The overwhelming majority of Earth's total volcanism, by number of eruptions and by sheer volume of molten rock produced, happens underwater. Most of it happens along the mid-ocean ridge system, an enormous chain of undersea volcanic rifts winding around the entire globe for roughly 65,000 kilometers. It's the longest mountain range on the planet, and it sits almost entirely submerged. Every year, it quietly produces more molten rock than every land-based volcano on Earth combined. So when we talk about the ocean hiding volcanoes from us, we're not talking about a handful of exceptions. We're talking about the main event. The planet's entire volcanic engine runs mostly below sea level, in exactly the one environment we're worst at directly observing. This new caldera survey, arriving the same year as both the Titan Ridge eruption and this earthquake, forces an uncomfortable question to the surface. If we only just discovered 73 of these giant calderas by accident using borrowed software built for a different planet, how confident can we really be that we'd notice if this hidden system started ramping up its activity? To answer that properly, it helps to look at what the underwater eruption record from roughly the last 15 years actually shows. It reads like a series of records that keep getting broken. Back in 2011 and 2012, a volcano called Tagoro erupted off the island of El Hierro in the Canary Islands, the first submarine eruption they're ever directly observed with modern instruments, disrupting the local marine ecosystem for months. In 2012, a volcano called Havre erupted north of New Zealand and produced a pumice raft stretching an estimated 400 kilometers, an eruption so far offshore that literally nobody noticed it happening in real time. We only found out once satellites spotted the floating rock afterward. In 2015, axial seamount off the coast of Oregon became the first submarine volcano ever watched live by a cabled observatory wired directly into the seafloor, and researchers there now believe it may be building toward another eruption later this year. Then, Between 2018 and 2019, an eruption near the island of Mayotte in the Indian Ocean built an entirely new volcano out of roughly 5 cubic kilometers of fresh lava, a mountain rising about 820 meters off the seabed. At the time, it was the largest submarine eruption ever documented through direct observation, and it announced itself with an earthquake swarm remarkably similar to what we're now seeing near Titan Ridge. Each of these events got labeled the biggest of its kind seen in years, and each of those titles got taken away within a few short years by whatever came next. Then came the eruption that genuinely changed how scientists think about what an underwater volcano can do. On the 15th of January, 2022, the Hunga Tonga volcano erupted, and it did something no eruption within modern memory had managed before. It proved the ocean isn't just hiding volcanoes from us, it's hiding volcanoes genuinely capable of reaching up and directly touching the entire planet's atmosphere. The blast injected an estimated 146 teragrams of water vapor straight into the stratosphere, raising the total water content of that layer by roughly 10% in a single stroke. One underwater volcano measurably altered the chemistry of the entire global stratosphere. It sent a pressure wave racing outward that circled the planet multiple times, picked up by weather instruments on every continent. It ranks among the largest eruptions since Mount Pinatubo in 1991 triggered a tsunami that crossed the Pacific and produced some of the most intense volcanic lightning ever recorded. And it did all of that from a volcano that, weeks earlier, almost nobody outside the region had ever heard of. That's the detail worth holding on to. Hunga Tonga wasn't some famous, closely monitored giant. It was an obscure submarine volcano on a remote arc, exactly the kind of feature that hides in plain sight until the day it suddenly doesn't. It belongs to the same family of features this new algorithm just counted by the dozen. So when a survey reveals 73 more calderas we had no idea existed, the follow-up question is practical. How many might be capable of producing another Hunga Tonga? Honestly, we don't know, and we wouldn't necessarily see it coming, because the same water that hides these features also muffles the small warning earthquakes that would normally give us advance notice. There's one particular place on Earth that shows just how strange this hidden underwater world can get. Far to the north, beneath the Arctic Ocean, runs a feature called the Geological Ridge, the slowest spreading segment of that entire global underwater mountain chain, pulling apart at less than a single centimeter every year. By every reasonable expectation, volcanism there should be sluggish and gentle. It also sits under roughly 4 kilometers of seawater, pressure so immense that explosive eruptions that were supposed to be flatly impossible. That was the accepted rule for decades. The Geological Ridge broke it completely. When researchers investigated the site of a major earthquake swarm out there, they pulled up fresh fragments of pyroclastic glass, the shattered frothy rock, that only forms during a genuinely explosive eruption, recovered from around 4,000 meters down. Something had exploded under 4 kilometers of ocean, in a place where the pressure was supposed to make that impossible. The explanation turned out to be chemistry. The magma feeding that ridge carried an extraordinary load of dissolved carbon dioxide, roughly 10 times what's typically found in ordinary seafloor lava. When that gas came out of solution, it expanded violently enough to blow the surrounding rock apart, despite the crushing weight of the ocean above. And then there's the question of sheer size. Consider Tamu Massif, a single volcanic structure out in the Northwest Pacific, so enormous that scientists spent years debating whether it might be the largest individual volcano on the planet. Its footprint covers an area comparable to the entire state of New Mexico, roughly the same surface area as Olympus Mons, the giant volcano on Mars, often called the biggest one in our solar system. It rises about 4 kilometers off the surrounding seafloor, built from thick sheets of basalt, laid down around 124 million years ago. And we didn't properly recognize it for what it was until sometime in the 2010s. A structure the size of an entire U.S. state sat essentially undetected on our own planet until barely a decade ago. Later research has complicated the picture, suggesting it may be built more like a stretch of spreading ridge than one single volcano, so its exact classification remains contested. But nobody disputes its scale. Tamu Massif is about the clearest possible demonstration of why a single algorithm could find 73 hidden calderas in one pass. If the ocean can hide something the size of New Mexico until the 2010s, hiding 73 collapsed craters is nothing by comparison. So is the planet's underwater volcanic system genuinely waking up right now? The honest answer is that we genuinely cannot be sure yet, and the reason matters. Our historical record of these eruptions is extremely short and only recently backed by instruments good enough to catch them properly. For most of recorded history, an underwater eruption simply happened, unseen and uncounted. It's only within the last decade or so that we've had the satellites, the cabled observatories, the pumice tracking, and now this machine learning approach capable of catching these events at all. So the apparent surge we're seeing, this run of record-breaking eruptions and the sudden doubling of the known caldera count, might genuinely be exactly what it looks like from a different angle. Not the ocean waking up, but us finally waking up to something that was always quietly there. That's the careful, cautious answer, and probably the most statistically likely one. But it isn't the whole answer. A historical record this short cannot rule out a genuine underlying increase in activity. We don't have enough data to confidently say nothing is changing beneath the surface, and the system we're now, for the first time in history, actually able to properly watch is enormous, barely monitored, and, as both the Gakkel Ridge and Hunga Tonga proved, capable of far more violence than the old textbooks ever allowed for. Before we wrap up, there's one claim circulating online that deserves a straightforward answer. There's a theory going around suggesting the planet is quietly waking up, and that a global surge in ocean volcanism is somehow being deliberately hidden from the public. It's worth addressing directly, because the honest response is also the more interesting one. None of this data is actually hidden. The satellite imagery comes straight from the European Space Agency and NASA's Earth Observatory, fully public. The earthquake listings come from agencies like the USGS and Germany's GFZ, likewise public. The volcano bulletins, the published research, the seafloor maps, all of it is genuinely out in the open for anyone to read. These events only feel hidden because they're physically happening under kilometers of ocean water, where no camera can realistically follow, and where the small warning earthquakes that would normally alert us slip right past our instruments unnoticed. The obscurity here is a matter of physics and ocean depth, not politics or cover-up. Nobody is deliberately concealing the seafloor. It's simply genuinely very hard to see. So what's actually worth watching going forward? First, Titan Ridge itself. The eruption remains active after more than 2 straight months, and the real open question is how it eventually ends. It could keep feeding pumice into the currents, affecting nearby coastlines for months to come. It could build up enough fresh material to break the surface and form a temporary new island, something NASA has explicitly flagged as a real possibility, and something a nearby eruption in this exact area actually hinted at back in the 1970s. Or it could simply fade out. Scientists are watching to see whether our instruments even manage to capture the eventual finish, and the July earthquake strongly suggests the underlying system is still very much alive. Second, the ongoing mapping effort itself. The July survey scanned the seafloor at a resolution of only about 500 meters per pixel across ocean that remains far from completely charted even today. Higher resolution mapping is already underway, and every improvement to that picture is likely to reveal more of these hidden structures. The real question isn't whether we'll find more of them. We almost certainly will. The genuine question is whether any turn out to be currently active, and whether we'll recognize the warning signs in time, should one of them ever do what Hunga Tonga did back in 2022. Here's what this whole story genuinely comes down to. The largest volcanic system on the entire planet is also the one we can barely see at all. It's currently showing every outward sign of active behavior right now, and we've only just recently built the tools necessary to properly watch it in the first place. Whether this represents a genuine acceleration in activity or simply the first truly clear look we've ever managed to get, the smart move stays exactly the same. Either way, keep a close eye on the water. We'll definitely be tracking Titan Ridge, the next round of caldera surveys, and any further earthquakes in the region as this story keeps developing. None of this means you should be losing sleep over it. Nothing here points to some imminent global catastrophe, and nobody credible is suggesting otherwise. What it does mean is that the picture most of us carry around in our heads, one where Earth's volcanoes are a short, familiar list of famous mountains, is genuinely out of date. The real list is bigger, stranger, and mostly sitting somewhere we've never properly looked. If you want to stay updated as this keeps unfolding, make sure you're subscribed and drop a comment below with your own thoughts on all of this. Thanks for watching, and I'll see you in the next one.